A burning issue, an investigative experiment. The following is an experiment I conducted named the flame test. My research question for the experiment was, how does the type of metal in a chemical affect the color produced when it is heated in a flame? My hypothesis statement was that I believe from my background in chemistry that the types of metal in a chemical will change the colors of a flame when heated within that flame. In my experiment, I needed a control group. My control group was the color of a normal flame on a candle, which is seen in this picture. From this picture, I can determine that the normal color of a candle flame is white in the center with a light yellow edge. Next, I conducted my experiment. This is a picture of the items and chemicals I used for the experiment. The items needed were safety goggles, water in a glass for extinguishing flames, measuring spoons, cotton swabs, cups, candle, and a lighter. The chemicals used in the experiment were 90% isopropyl rubbing alcohol, used as a solvent in the experiment. The solutes used in the experiment were sodium chloride, table salt, potassium chloride, which is found in salt substitute or no salt, copper chloride, pull shock algicide treatment, boric acid, roach killer, potassium bitartrate, cream of tartar, and calcium sulfate, plaster of Paris. To test my hypothesis in my experiment, I mixed separately for each chemical in a separate cup 1 tablespoon of alcohol and 1 tablespoon of each chemical. I soaked a different cotton swab in each mixture and put the soaked cotton swab within the flame and recorded my results. In my conclusion, the results I found was that yes, the different metals within a chemical affect the color produced by the flame. For example, if you look at this flame, the outer edges of the flame have a much more pronounced yellow color. This chemical ignited is sodium chloride or table salt. This chemical produced one of my favorite colors. See the beautiful green hue? This chemical is boric acid, or powdered roach killer.
Hey, Kara, I thought this was a really cool experiment. I love hands-on stuff like this. Anytime you can get in the classroom and practice what you're teaching, I think is a positive experience. And I know when I was a student in chemistry or any science class I loved to get in front of you know, the big desks and the flames and the beakers and all that stuff. So this was really cool.
In doing this experiment, I was inquisitive and wanted to know why or how does these chemicals change the color of my flame. The answer to this question can be found within an atom. When an atom is excited to higher energy levels, such as when it is exposed to a flame, like my candle, the electrons become excited and they move to a higher orbital. Eventually, these electrons decay or rest back onto a lower orbital. When they do this, they emit a photon or a light. Then I asked, why do the different chemicals produce different colors? I found this answer within atoms and the electromagnetic spectrum. The color of the light is determined by the location and number of electrons each atom has. Depending upon this number, they give off a certain wavelength of light and color from the electromagnetic spectrum. If you recall, the color of the sodium flame was yellow. That is because the electrons emitted a yellow wavelength, which you can find here on the electromagnetic spectrum. You may be asking yourself quite simply, putting aside all the science behind this, is how does this directly relate to us and our lives? Believe it or not, the science is all around you and I, and involved in our normal activities. Here in this picture, you may notice the familiar yellow glow. Remember the yellow color of the sodium chloride or salt flame? They are one and the same. These are sodium lamps, or what we most commonly refer to them as street lights.
What a terrific application to real life knowledge. I know I'm one of those students who sits in the class and wonders, why am I learning this? And I used to be at times. And so great for you, Kira, to mention how this is related to students' everyday lives and really explain for even me to understand how these lights look the way they are, because they do always look so different in the nighttime compared to the basic lights that we might see during the daytime, and it's all related to that sodium chloride substance, and that's pretty neat to know.
Scientists also use the flame test in a machine. It is called flame emission spectroscopy. They use this machine to test for potentially harmful chemicals such as lead. Since all lead atoms give off a certain light or color, they can determine by this color if lead would be present in your water supply. Pharmacists also use this in making compounds or medicines that you may buy at the pharmacy.
Hey Kira, enjoyed your presentation. Thought you did a very good job systematically going through, which in science I think is pretty important, with laying out the question, hypothesis, your control, your ingredients. And then I thought you did a good job of showing that these chemical properties and differences between different chemicals exist even if you can't see them, which I think is hard for people to see, especially middle school students who might be in that stage where they're being able to go from understanding concrete things to handling a little more abstract material. And then I thought the last couple slides where you added the relevance, because that's always something students want to know is, well, how is this in the world, or how is this going to affect me, or does affect me. So I thought that was good as well. So good job overall.
Your presentation represents an excellent usage of the Voicethread program. You gave great information in each slide. The experimental hypothesis was established, the necessary tools listed, the experiment was performed, a conclusion was stated, follow-up information was given, and the application was supplied. All of the information you gave was relevant and easy to follow. I believe this would be a great video to use in a flipped classroom. I wish that the assignment had allowed for more slides, because I would have loved to have seen more of the experiment as it was conducted. I also thought you did a great job incorporating the doodle. It enhanced the overall explanation. If you did decide to use this as a flipped classroom supplement, I would probably add some sort of disclaimer about burning chemicals. Middle school students can sometimes be a little too inquisitive for their own good. Thank you very much for all of the hard work you put into this presentation. It was well worth it.